Welcome to Chapter 8, Section 3, Geometric Sequences, Part 1. We're on page 426. We're going to cover topics on 426 and 427 today. Okay, and the first thing is just how do we identify that a sequence, a list of numbers, is geometric? What we are going to look for is the common ratio. So on page 426, let's write number 1 together. 27, 9, 3, 1, 1/3, and so on. Okay, so here's what they give us. So we want to see, is there a number that we can multiply or divide by every term and get the next number, okay? So to figure that out, remember we're going to go from right to left, so 9 divided by 27. Okay, so 9 over 27 is 1 over 3, okay? Well, what about 3 over 9? 3 over 9 is 1 over 3. What about 1 over 3? That's 1 over 3. And what about 1 over 3 divided by 1? Well, that's just itself. So do we have a common ratio? Yes, we do. That common ratio is 1/3. Yes, it's geometric. Give a reasoning. The reasoning is that there is a common ratio of 1/3. And you know what? Mentally, just check your work. The common ratio is 1/3. So what is 27 times 1/3? It's 9. What's 9 times 1/3? It's 3. Is this list going down in value? Yes, it is. So the common ratio has to be a fraction less than 1 bigger than 0. Okay? So yes, it's geometric. The common ratio is 1/3. That explains our reasoning. Let's take a look at number 2. Okay, so for number 2, the sequence is 2, 6, 24, 120, 720, and so on. Is there a common ratio? 6 divided by 2 is 3. 24 divided by 6, oh, that's 4. So, nope, there is no common ratio. No, this is not a geometric sequence. There is no common ratio because I just took the first 2 pairs, and when you divide right over left, then you get a different number. That's your reasoning, okay? Why don't you try number 3 right now, okay? Something familiar with number 3. And then when you're ready, you're going to catch up to me with number 4 on page 127. So on page 427, I don't know why I said 127, number 4 is 3, 15, 75, 375, and so on. The directions are to write a rule and to find a sub 9. Okay, so first, let's do 15 divided by 3, and that's 5. 75 divided by 15 is 5, and I checked with my calculator. 375 divided by 75 is 5, so my common ratio is 5. Now, the core concept on page 426 tells us that a geometric sequence follows this basic rule. This is an R. A sub n, the next term, is equal to A sub 1, the first term, times the common ratio to the n minus 1 power. So whatever term you're talking about, take away 1. That's your exponent. All right, so this is actually kind of simple. We're just going to write A sub n equals, what's my first term? Well, they told us, it's 3. What's my common ratio? We found that out. It's 5. And then finally, we don't have to do anything here. N minus 1 is our exponent. Now to find A sub 9, I'm going to substitute in 9. That's equal to 3 times 5 to the 9 minus 1 power. Well, 9 minus 1 is 8. So what I'm really doing is 3 times 5 to the 8th power. And I'm going to pause it right there while you do the math and come back and you can check your work with me. All right. Did you get 1,171,875? Because if you did, that is the correct answer. If not, check to see what you plugged in. If you did 9 minus 1 already in your head, when you plug this in your calculator, 3 times 5 caret 8, it should just work out. But maybe something happened, okay? I do want you to practice before you move on to part 2. So turn to page 430. And I want you to do numbers 15 and 17 Okay, and then check your work in the back of the book and ask me any questions tomorrow in class, all right? So one more time, I'll write that down. Oh, if my marker just gets out, it's page 430, numbers 15 and 17. Remember, you are supposed to go back, rewind. If there's anything you need to, copy down again, and make sure you take good notes, all right?